Hello viewers, this is Wagada Ronald taking you through today's tutorial, and this video we're going to talk about the solutions to A-Level Math Paper 1 for UNEB 2019, and particularly we're going to concentrate on questions 15 and 16. So these are the very questions I left in the previous video, and now we are going to look at their solutions. So I believe by now you already tried them out and you are eagerly waiting to mark yourself. So let us get started. So we shall start with question 15. Question 15 part A says, differentiate y equal to 2x squared plus 3 from first principles, and those are 4 marks. So let's first do part A. First of all, you should let this symbol to denote the small change in y when x is incremented by small change in x. When you do that, you have to remember that this is what they want you to differentiate. But from first principles, what you do, when I increment the y by small change in y, x will also be incremented by small change in x. So this will be our next step. Y is incremented by small change in y, x is incremented by small change in x. Next is to expand this part. So when I expand this part, I'll come up with 2x squared plus 4x multiplied by small change in x plus 2 multiplied by small change in x squared plus 3. Now, but remember that y is equal to x is equal to 2x squared plus 3. So what does that mean? So this means that where there is y, I'm going to put there this, and when I do that, I'll come up with this, because this y is equal to 2x squared plus 3. So that means that this will cancel and this will cancel with y. So I remain with small change in y being equal to 4x small change in x plus 2 small change in x squared, which is that part. Now next will be to divide throughout by small change in x. When I divide throughout by small change in x, I'll come up with this. So in this case, this will cancel with this and this will reduce this. So when I do that, I'll come up with small change in y, small change in x being equal to 4x plus 2 small change in x. Then after that, I'll have to remember that dy dx is equal to the limit of small change in y, small change in x as small change in x tends to 0. What does that mean? It means that you come at this small change in y, small change in y, and put there where as this one tends to 0, we shall come up with this. So 4x plus 0, I'll get 4x. So basically, this is what they wanted in this part A. So I've been able to differentiate 2x squared plus 3 from first principles to get 4x as my answer. So now let's see how marking can be done. So the first mark here is for this part, and this one is for division. This one is for the substitution of the limit of small change in x tends to 0, and this one is for the output, which is for x, and that's what they wanted. So basically, that's how the 4 marks can be got. So now we shall go to part B. Part B says, a rectangular sheet is 50 centimeters long and 40 centimeters wide. A square of x centimeters by x centimeters is cut off from each corner. The remaining sheet is folded to form an open box. Find the maximum volume of the box, and they give it 8 marks. So here, the best thing to do is to remember to come up with a sketch first. So this was a rectangular, it was rectangular sheet with 50 centimeters, 40 centimeters, which is this. So from here to here is 50, from here to here is 50. But they told us that a square of x centimeters by x centimeters was cut off from each corner. So at each corner, I'll cut off a square of x centimeters by x centimeters. Then they told us the remaining sheet is folded to form an open box. So when you fold it, means 40 minus 2x, because this x and this x will give you 2x. So here there was supposed to be a 2, and also here there was supposed to be a 2, so that this will now become 50 minus 2x, and also this one 40 minus 2x. So when I fold it, I'll come up with this, which with a length of 50 minus 2x and width of 40 minus 2x and height of x. So when I do that, I'll come up with, so now they want us to get, they told us that the remaining sheet is folded. Now find the maximum volume of the box. So basically that's what they want, the maximum volume of the box. So we shall come and say, for the box, you already saw that the length is 50 minus 2x, the width is 40 minus 2x, and the height is x. So what does that mean? It means that now the volume will be equal to length times width times height. So length times width times height to give it that. Now when I expand that, I'll come up with this, and when I expand further, I'll come up with this expression as my volume. So volume is equal to 2000x minus 180x squared plus 4x cubed. So now the condition for maximum or minimum volume is that the derivative of this volume must be equal to 0. So what I'm going to do, I'm going to differentiate this volume and equate it to 0. So when I differentiate, I'll come up with this. So differentiate 2000x, I'll come up with 2000. Differentiate 180x squared, I'll come up with 360x. Differentiate 4x cubed, I'll come up with 12x squared, equate it to 0. Now this is the quadratic, and I can use a bulldozer method to come up with the values of x. So either x is equal to 22.6376 or x is equal to 7.3624. So before I go to the next slide, let's first see how much we have got in this part. So now here the first one is to get this expression of volume, then this mark is for derivative, differentiating, and this one is for equating the derivative to 0. This one is for solving. Using solving, you can use bulldozer or factorization, but bulldozer is one which works best because this one has no factors. Then this one is for the output, both values of x as that and that. So basically I've now got 1, 2, 3, 4, 5 marks in this slide. Let's see the remaining marks in the next slide. So we have already got that x is equal to this and x is equal to that. So what we are going to do, there are two methods, but let's start with this one. So we know that volume is that, so when x is equal to 1 this, I'll come and substitute x where there is x here to get the volume for that corresponding value of x, and that volume will be equal to negative 564.225. Do the same for this. When x is equal to that, substitute and get the value, so that value will be this. So when you compare these two, this one is the maximum, so therefore you come and conclude that maximum volume will be 6,563.89502 centimeters cubed. However, there's also another method of derivative. We know that maximum, you can get the second derivative test. Now if you use the second derivative test, we shall come here and say, for this one I have to get the second derivative, which is this, and when I substitute when x is equal to 22.6376, I'll come up with my second derivative as a positive, meaning this volume is minimum when x is equal to that. But when I carry out the second derivative test on this value of x, I'll come up with a negative value, meaning the volume is maximum at this value. Therefore, I'll come and substitute this value of x in this expression to get my maximum volume. So basically, those are the two methods. You can use the second derivative test, or you can use this one whereby you first get the volume for each value of x and you compare to see which one is greatest. Any of the two works. So now let's see how marks can be awarded. So getting this is 1 mark, getting this is 1 mark, and concluding is another mark. So basically that's what they wanted in that part. Now we shall go to question 16. Question 16 says, Part A, find the integral of ln x over x squared with respect to x, and they give it 4 marks. So I think let's first deal with part A. So what we are going to do, we shall say let u be equal to ln x and dv dx be equal to 1 over x squared. From there we shall use the x formula for integration by parts, but before you use it you have to first get the derivative. So if you use this, du dx will be equal to 1 over x, and if dv dx is this, then u will be equal to the integral of this to come up with negative 1 over x. Now when I substitute in this expression for integration by parts, I realize that uv, it means that u, which is this, multiplied by v, which is this, so this times this, I'll come up with negative ln x over x. Then integral of v du dx, v du dx, so this times this, I'll come up with this times this. And when I integrate, this is the same as the integral of negative 1 over x squared, and when I integrate negative 1 over x squared, I'll come up with positive 1 over x, which is this. But this one is already known, so come and put it here. Since there are no limits, you have to put the constant of integration. So basically that's what they wanted in part A, and let's see how marks can be awarded. So this B1 is for getting this value of v, and the value of du dx will come up with that B1. Then this one is for substituting in this expression for integration by parts. So substituting, you get that mark. Now this M1 is for you to integrate this to come up with this. So when I see this positive 1 over x, I'll give you that mark. And this one is for the overall output, for you to write the whole of this with the constant of integration. Remember that constant of integration has to be there for you to get this A1. So basically that's how the 4 marks could be got. Now let's go to part B. So now we shall go to question 16, part B. Part B says that solve the differential equation dy dx plus y cot x equal to x, given that y is equal to 1 when x is equal to pi over 2, and they give it 8 marks. So this is the equation which is given, the differential equation. What we are going to do, we are going to first get the integrating factor. This if means integrating factor. It's given by exponential of the integral of this coefficient of y. So the coefficient of y is cot x, so you integrate cot x with respect to x. When I integrate cot x, I'll come up with ln sin x. Now exponential of ln sin x, this can cancel to remain with only sin x, which is that. So basically the integrating factor is now sin x. What we are going to do after getting the integrating factor, multiply that integrating factor throughout. So sin x times this, I'll come up with this part. Then sin x times the whole of this, I'll come up with this part. And sin x times this, I'll come up with this part. Now from there, I have to remember that the derivative of y times the integrating factor is d dx of y times the integrating factor is the whole of this up to here. Then this side I remain with x sin x. Then from there, I'm going to put integrals on both sides to come up with this step. Then from there, remember that this integral and derivative cancel to remain with only y cos x. But this one is a product, so I have to use integration by parts. And integration by parts, I can use the table, which is a simpler form. Now this table, I'll put a column for sign, which is positive, negative, positive. Then the column for differentiation and column for integration. Now the column for differentiation is you put there this x, which is here. Then the column for integration, you put there that sin x, which is here. Okay, now for this part you will keep on differentiate. When I differentiate x, I'll come up with 1. When I differentiate 1, I'll come up with 0. So because I've got 0, it means I'll stop here. For this part of sign, you begin with the positive, go to the negative, go to the positive, and so on. Then for this part of integration, you begin with sin x, which is here. Now when I integrate sin x, I'll come up with negative cos x. When I integrate negative cos x, I'll come up with negative sin x. So basically that's how how the table can be filled. Now next is how to use it. How are you going to use it? You will say this, it means that now this integral will be equal to this times this times this, which is to give you x negative x cos x, then plus this times this times this to give you what? To give you positive sine x. So when you do that, you shall come up with this expression. For this one, this cancels, you remain with y cos x. For this part, you are going to get negative because of this negative x cos x, which is that, and this negative gives a positive to get positive sine x. But don't forget the constant of integration. So we have finished integrating, but now this is what we call the general solution, because there is still a constant of integration, general solution of this differential equation. But remember, they want the particular solution. How do you get the particular solution? You use the initial conditions given. The initial conditions were that y is equal to 1 when x is equal to pi over 2. So let's see how that can be used. So when y is equal to 1, when x is equal to pi over 2, y is equal to 1. Therefore, come here and substitute. Where there is y, put there 1. Cos pi over 2 is 0. Therefore, 0 times 1 will give you 0, which is this part. Then for this part, pi over 2 times cos pi over 2 will be 0, and sine pi over 2 will be 1. Then c is here. Now when I make c the subject, I'll come up with c as it being equal to negative 1. Now that I've got c, I'm going to come and substitute it here. So substitute that value of c here to get the particular solution which they wanted. So basically this is what they wanted in this part. Now let's see how marks can be awarded. So the first mark is for getting this integrating factor. The second mark is for substitution into the given differential equation. This one is for simplifying to come up with this, and these 2 marks are for this table. One is for that part, and the other one is for this row and row, second row and third row. Then these m1s and this one, the first m1 is for this integral, output of that integral, and this one is when you use this table correctly to come up with this output, you get that 1 mark. So the whole of this output, you get that 1 mark. Now this b1 is for getting this value of c using the initial conditions, and this one is for the particular solution. So basically that's how the 8 marks will come about. So I believe you have marked yourself and checked your progress and now made corrections where need be. So now I'm going to leave you with 4 questions, but these questions will be questions for applied math. We have been dealing with pure math, now we are going to applied math, and I'll leave you with 4 questions for section A, and each question will be carrying 5 marks each. So let's get started. So I've left you with those questions, and I believe in the next video the solutions will be there and you'll be able to to mark yourself. So try them out before the next video is released, and if you have not yet subscribed, please click the subscribe button below so that you get updates on each video that I upload. So when the video is out, you'll be able to receive the update. And also use that share button, share icon, to share the link of this video to as many students as possible via WhatsApp, via Facebook, and via any social media. Otherwise, thank you for watching, and please don't forget to subscribe and also share with as many students as possible so that we all excel as a family.